I'm CK. Tonight we're going to be starting another kit from Elenco. It's their regulated portable power supply, DC power supply, and this is going to be two videos, not just one, and I'll tell you why. As you may be able to see from the picture here, and you'll be able to see better when I put it on the benchtop, setting the power output voltage is a potentiometer with no markings on it. You just have to get used to where the voltage you want is. So I'm going to put this together as a by-the-book kit, put that video up, then I'm going to take it back apart and add a digital display to it so you can see the voltage value at the output. So two videos will be coming out of this one box, and I hope you enjoy the video. The box: learn to solder and build a regulated variable voltage DC power supply. Output voltage 0 to 15 volts DC. Output current 0.2 amps at 15 volt, 0.3, so 200 milliamps at 15 volts, 300 milliamps at 12 volts, which means it's not very powerful. Overload protected, IC thermal protected. Handy portable power supply for students, technicians, and hobbyists. And that's why I got it, because it's always good to have more power supplies. A bunch of information: tools needed: soldering iron, Phillips screwdriver, diagonal cutters, and long nose pliers. Ages 12 and up. So that's it for the box pretty much. And we make tools for makers. Elenco when the maker movement became hip, Elenco started adding that phraseology to a lot of their packaging to try and fit in and be hip. Okay. Nice little plastic backing. Sure are a lot of ports there, or a lot of holes there. I mean, there's the, if I look at the front, there's the power, but then there's a lot more holes for various things, unless there's a faceplate or something that goes on top of it. There it is. Let me take everything out of the box. So yeah, so the faceplate covers up most of these holes. So it'll just go on like that. As you can see, DC voltage from 0 to 15, and it's just a potentiometer to adjust that, so that's not very accurate. I bet they use this box for some other kits. I would. That's why they have so many holes in it. So as I said in the intro, I'm going to put this together as is. Then I'm probably going to add a digital voltage display here on the front. I've got one right here that I will mount somewhere on the package so we can get an actual DC voltage instead of guessing where the knob is. So there's the case parts. That's fine. Got some paper padding, which is good because it's recyclable. It feels like we've got a power supply transistor in here, I mean transformer in here. Yep. This will be a, let me get the little plastic bag off it and see what we've got on the various wires. Oh, it doesn't say. Many transformers tell you what their output is rated for. This one doesn't. There's the input, obviously, or clearly. Look at this. The insulation sticky tape is coming up a little bit. That's not great. This is a medium quality transformer, not a great quality transformer. We've got a bunch of stuff in here. Oh, not a bunch of stuff. We got a power cable. Okay, that's pretty boring. I mean, it's not boring. It's desperately critical to operation, but not something to talk about. There's a bag with the parts and a piece of paper. So we'll get this box ready for recycling. And here is the manual. This will be the build manual, and typically in Elenco products it will also tell you a good bit about the theory of operation. So it's got all putting everything together well, testing it, and here's the circuit description, which is really good, some good diagrams, and how the voltage regulator circuit works using an LM317, and then a troubleshooting guide just in case it doesn't quite work. And look at this, it's got a quiz too, so make sure you do your quiz when you do this. And here is the schematic coming in from mains, going through the transformer, diode protected down into here, and here's the LM317 regulator with voltage in, voltage out, and here's the rheostat on the front that will control the positive pin and the going back to ground, the circuit. So that's the rheostat going to the IC, and some various other caps and diodes to keep things working correctly. And the answer key is on that page, so don't look. Do your quiz without peeking at the answers. So we got in here a tube of solder, which we will never ever ever use, but I do appreciate that they put it in there for people who don't have a bunch of solder. Little electrolytic caps, slightly bigger, and a big old one. How big is this one? That's a 220 microfarad 35 volt cap, and here's the 317 voltage regulator. Some rubbery feet, bunch of diodes, 3 resistors, and an LED. Screws and washers. Here's the circuit board, a very simple circuit board. I'm looking for isolation. Again, I'm not sure it's not highest quality, but it would be great for a power supply. And then here we have our terminals for power, the actual potentiometer. It's a B202, so 20 plus 2 zeros, 2000 ohm. And a little bracket, and that's pretty much it. So it doesn't look like it's going to be too complicated to assemble. So I'll get the soldering iron heated up, and we'll put this little fella together. So let's dive into the book and see what we want to do first. I think first thing we're going to do is mount the transformers and binding posts. So the transformer apparently goes on the front, mounts to the front, primarily because it shows mounting holes and the back has no mounting holes. And the front has all the mounting holes. Now, okay, they do. Okay, first thing we do, I was wondering, first thing we do is put the front panel plastic sticker on the case, and we try and do it carefully so it's not all cattywampus and the components won't fit. First, get the random pieces of cat hair off it, make sure we're going the right direction, and we are, and it fits very well. That went on pretty easily, and the holes all line up very well. Let me get the backing again and rub it down really hard so the glue will adhere really well. Okay, good. Now I can bring my instruction manual back. This thing is a little funny. Now I'm going to take my display and put it to the side for right now so it's not in my way. Where are the nuts and so on? They are here. I'm going to dump them in their own bowl. Because we're going to be stacking the nuts in a particular way. So we're going to use the two 6/32 by 3/8 screws to mount this guy. So I'm going to put them both through the front like so. Then hold them and set that down on my workbench. And we're going to put a fiber washer down. There are these little fiber washers, which is now dancing around in here. Put one fiber washer on each screw to start. Oh, they wanted to put the binding posts on first. I'm actually not going to put the binding posts on first, because if I put the binding posts on first, the thing's going to be all jacked up when I'm putting the transformer on. So I'm not going to do that. I'm going to put the transformer on first. Now, we'll put the transformer on, as I was just ranting about, with the AC inlines on that side and the DC outlines on this side. Now we do another fiber washer. One on each screw, of course. And lock washer appropriate to the screw size. And then the two nuts to hold the little guy on. And I'm just going to get a couple of threads caught to start. I wonder why there are three of these. Huh. There aren't. There's one little screw, little nut that I don't know goes to that screw, and I don't know what that's for. We'll see in a little bit. I really don't know what that's for. Okay, so we've got these screws started. Now that they're started, we can crank them down. And with that lock washer and those fiber washers, you really don't have to put a wrench on the nuts because there's enough retention between the elasticity of the fiber nuts and the ridges on the lock washer that you don't really need to put a wrench on it. So there, transformer is on. Now we'll put the binding posts on. Again, I would probably change those instructions to do it in the sequence I'm doing it, simply because if I wanted to do it the other way, I'll show you here in a second. Oh, I'll use a different tray. It's got two screws already in it, which is bad because that'll confuse me, but that's okay. Because once I put these guys on, we've got two lock washers for these, and two large mounting nuts, which, be careful with this, because this, you're not going to be too aggressive on these, because this is plastic. These posts are plastic that we're putting metal nuts onto, which is a little bit, you have to be a little bit careful that you don't strip it out. I bet this case, looking at all the holes on there, I bet this case is also for a meter or something like that. Does that make sense? That'd be your 3 voltage ends and then some current and switches to go with it. I'm just speculating now. But again, you don't want to tighten these nuts overly aggressively because it's metal nuts going around plastic threads. So it's very easy, as you can imagine, to strip those plastic threads. So just don't be super aggressive on it. Now that's what I was saying. If we had put the binding posts on first, this would have been it would have been at an angle while we're trying to get the transformer on, and I preferred to have it flat while we were doing the more complicated task. So that's step 1 and 2 and 3. Cut the red wire on the red wires come off. Okay, we're not using those, we're not using this output. Again, I want to see what this transformer is. And it'll call out the transformer in the parts list. That's kind of weird. Oh, there it is. YD 1485 doesn't show the specs, so I don't know what the voltage coming off the red wires is per the instruction. Cut the red wires off. And we will do that. Now typically what I do here is, yes, I've cut the red wires off, but hold on a second, I got to get something out of my parts closet. I'll be back in a minute. So I generally don't like to just have wires trimmed and with the leads exposed like that. Why did you hop so far away when I cut that? I just cut a little piece and I'll find it later. So I'm going to take some shrink wrap and I will put it around the ends of these wires and shrink it. So I'm going to turn the power on my heater up, so you'll hear that in the background while it warms up. But I'm just going to slide this shrink wrap over the ends I just cut the wire from. And then just run the heat gun against them, shrink it up. And that's it. And now that's pretty paranoid to worry about accidentally maybe touching that and shocking myself in the future. But being cautious is a good thing. Now we're going to go ahead and populate the board with all the magic bits that go on it. And the way Elenco does it, which I certainly appreciate. Here's the steps pointing to the places on the circuit board where it goes, and there are C figure D, C figure C for information like how diode polarity works, how LED polarity works, how the capacitors are polarized. The manual is really good for someone who's starting out. That's why they list this at 12 plus. So let me get these other bags open. And we'll just go through the steps. Take the 220 microfarad, goes in C4. This looks 220-ish, doesn't it? It does. Goes in C4, and the circuit boards have very clear plus and minus indications for how the leads go on. Now we're going to do the 401 or 4001 diodes. There are a bunch of those, aren't there? There are. So I'm going to go ahead and kind of skip around a little bit here and put all the 4001 diodes on right now. White stripe on the diode to the white stripe on the circuit board. And I'm going to, and diodes go there, 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 and there, and they're all 4001s. So I'm going to speed up the playback and turn down the commentary volume because I don't have much to say at this point as I put all these diodes on. All the diodes are on, and this board is nice because you can still see the white stripe after you put the components down, so you can double check. Always look and make sure you've got your polarities right. Now we'll put a couple of resistors down. Then the 4.7, which is right here. And when you get these components on tape strips, I like to just cut them out instead of trying to fight around the tape. You might not want to because that does take away the long leg, and you have to focus on the white stripe to show you where the negative side is so you get the polarities right. Now we've got some attachments for wires. Oh, and we're going to use the cutoff transformer wires. I'm not going to do that right now. I'm going to finish up the other components. And now we do the 2200 microfarad cap, which I just stupidly did put my fingers across like that because I'm dumb. Try not to do that. Try to be smarter than the guy you're watching on YouTube, because I could have gotten a very noticeable shock had that been charged, even atmospheric charge. Now we'll do R2, 150 ohm. Now we'll do the voltage regulator. So we're going to put the voltage regulator together before we put it on the board. That's the way I like to approach this. Different people can do it different ways. So, but I like to kind of get it loosely together right at the outset and then adjust it once we get it on the board. Primarily because since the performance of this regulator, any transistor style, any voltage regulator like this really depends on how much heat it can dissipate. So to help it do that, I'm going to put a little bit of thermal paste on the back. Not a lot, because it's all messy and you don't need a lot. It'll spread out very well once we put it on this little tube of thermal paste. Gonna last me years. Go ahead, buy some off Amazon or wherever you buy your stuff. So I'm going to smear it around a little bit, just right here. You can see it covers a lot of surface area. Now I'm going to drop the screw through, and then I'm going to put the nut on the back, only finger tight. Now I'm going to drop it through. The heatsink side, the metal side here, the big piece of aluminum, goes where that box inside the box on the silk screening goes. And as you can see, fits on kind of like that. Heatsink is hanging out in the air. Let me bend these leads a little bit, and I'll solder this down. So now, I've got it mounted. It's pretty much vertical, even though it doesn't have to be vertical, of course. Now I'll tighten this the rest of the way down. So the diode goes here, but it goes on the back of the board. As you can see here, it goes on the back, same as the potentiometer is going to go on the back. And they want you to leave 3/8, and I'm doing that wrong. That's right, because the flat side goes on this side, and we can double check that, yeah. And they want 3/8 of an inch rise off. Let me see why. Where's the front panel again? There's so many pieces of stuff floating around. Oh, I see. There's a little hole here for the LED to go through. I'm going to do some test fitting here to get a good sense of how this will fit into this case. So if that sits flat like that, that will go roughly like that. That will go like that. So with that like that, you can see that's how the power LED shows through the front. And I want it going all the way through the front instead of a little bit, so I'm holding it flat. And there's no solder on this side for me to be able to adhere that. So what I'm going to do is going to take a little marker and mark the legs. Now I'll take it back out and put the legs where that mark was again. And I'm going to measure that. I don't think that's 3/8. I think that's significantly more than 3/8. Maybe they didn't want the whole LED coming out the front. I don't know. Now that we've got it marked, I'm going to take a little piece of painter's tape, which I always have handy, and I'm going to wrap this so the edge of it is right where the black line that I put on there with the Sharpie is. Build it up a little bit. Now push it forward. Now that's exactly the distance I'm going to want, because that tape is holding it there. So I will now solder that on this side of the board. That's one leg soldered, which means I can take the tape off now. And I'm only soldering one leg right now because I want to see, now that we've got the component in, if it still goes through the front case the way I would like it to. And it certainly does. So I'll solder the other leg. Now I'll go ahead and solder the potentiometer all down also. And that also needs to be done on this side of the board. There's that pot done, but I probably need to trim that off. There's a little index. Oh no! They have a hole for the index pin, so don't have to trim it off. Good. Now I'll go back and put those two pieces of wire on. These are the two pieces of red wire that we cut off the transformer a little while ago. And we'll strip a little bit of wire off each. So that's the control board. Now we're going to mount the rest of it. So as you can see, there are no mounting holes on this board. The board is going to be held in place simply by the panel nut on the shaft of this potentiometer. So it's not really all that secure. I may do something about that when I go back in here, when I do the modification I'm going to be doing. but for right now, we're just going to finish up the stock way of putting this little fella together. So now we're going to mount the wires from the transformer on, and P1 and P3 are where the yellow wires go. Get those in place, even though again they tinned this lead, and some of the solder is sticking out, so it's not going quite through the hole as well as it could, so I'm going to try and smooth it a little bit. Oh, it looks like a piece of wire actually doubled up. That might work. Yeah, that worked just fine. So we'll solder those two pieces of wire. So that's those wires. The next thing we're going to do, and I'm just making sure we've got our direction correct, is we are going to put one of these on the negative side, and that will be P4. I believe P4 goes to black. Get my little bendy pliers, which are in fact just needle nose because I grabbed the wrong thing. So that wiring is done. And now we will actually put the potentiometer and the LED through the front. And again, the potentiometer has that little tang so it won't rotate. Yeah, these nuts that came off the posts are done because I won't need them because I soldered them on. Now we're going to take a washer. Tighten it. You do want to put a certain amount of tension on this one because this is the only thing holding the circuit breaker in place. I mean, circuit board in place. There, so that's good. Now we can put the knob on it, and we want to go all the way counterclockwise and get the line lined up with 0, or close. I often get that wrong. Yeah, I could go a little bit the other way. I'm not gonna, because I'm actually going to put the real thing on there. Never mind, I'm mumbling to myself. Okay, so that's basic assembly. We still have to add the power cord, and we'll do that in a minute here. But that's basic assembly of what it's going to look like on the inside and on the outside. And now we will do the AC power. I'm stretching these. He's got a little scrunch during transit. So we'll get a strain relief. I'm not going to tighten the strain relief right yet, I don't think. Sorry, the camera battery died in the middle of that, so I don't know where we ended up. I know I was putting the cable through, so the power cable is through now, and I hope I caught that, getting it all together, but we'll see. Next, we're just going to connect the mains to the transformer input. They gave us a piece of shrink wrap that we can use to protect these leads after we've got them soldered together. Which means I got to go get I had put my shrink wrap heater away. I'll grab it back out. So that'll be ready for us when we're ready. We'll take the shrink wrap and I'm going to slide it all the way down the wire so it doesn't get, I'm not going to trim these wires much. I'm going to lay them down kind of like this and down this way. No particular reason, I just feel like it tonight. I don't mind having the extra wire. There's so much space inside this case that I can do that. So let me solder this one. Heat the wires up. Get a little solder flow going. You want these obviously to be pretty good connections. So that one's really solid. Now we'll take our shrink tubing and run it down the other wire. And if I can only say it, always remember to put the shrink on before you solder. I can only say it because there have been a number of times when I have forgotten it too, and I'm sitting there and I got the wires nicely soldered together and the shrink tubing sitting on the workbench or whatever. Very frustrating. Now I'll turn on my heat gun and let it warm up a little bit. That's good. Now we won't get shocked by anything. Now we can lay all these wires down. Again, I left them longer than you might want to do. They say we can put the rubber feet on this, but I don't think I'm going to do that right now because I'm going to be messing with it a bit more. So we put the Alright, that's it all put together. Let me tuck some tools away. Now I'm going to go ahead and give this guy a try. Set my meter on DC voltage. And what I'm going to do is I'm going to plug this into the wall, and that should turn it on. As you may have noticed, there's no on-off switch for this thing. So the LED should turn on as soon as I plug it in, or everything might blow up. Nope, turned on just fine. Got a nice little light. I'm going to turn it all the way down to nothing. Put my meter leads in the plus and minus. Is this too glary? No, you can see that. Let me turn this off for a second. Like it off or on? On. Okay, now I'm going to take the voltage pot rheostat up. Potentiometer up. So at the first graduation, it's 0.9. Second graduation, it's 2.2. Third graduation, it's 4.2, 5, 8, 12, 11, 13, 15. I thought it only went up to 15, guys. 16, 18. So it goes up to 18 volts, even though it's only rated at 15. It's part of the reason why I put that thermal paste on the back of the power regulator, voltage regulator, because that's going to get hot, particularly if it's over what it was originally, the circuit was originally designed for. But if it can dissipate the heat well, then it shouldn't be a problem. So this goes from 0, basically, up to 18.5 volts. So it's a good little unit. And again, you can carry this around the shop. Might be easier than getting your benchtop power supply or dragging something over from your benchtop power supply. But again, now that I've seen it in operation, I can see that this range scaling is completely inaccurate. So when you use this, you're going to have a meter and actually dial in your voltage before you actually apply it to whatever load you're going to be powering. So just be careful about that. Don't rely on these graduations, and 15, as you saw, is definitely not the limit. So that's that. It's a quick build. The only actual problem part was putting this strain relief through, but we got that done. I think for a 12, 13, 14-year-old who wants a power supply around their developing shop, this would be just grand, and the price is pretty good. So I can recommend this. Now stay tuned for part 2, which is where I'm going to take this back apart and add a digital voltage display so we don't have to guess at what our output voltage is. If you don't want to watch that, that's fine, and I hope you enjoyed this video.